Imagine this. Everything you know, everyone you love, every single atom in the universe, all of it inside a black hole. Sounds crazy, right? But what if that's exactly where we are? What if this entire universe is tucked away in some cosmic giant, hiding somewhere in a much bigger universe? Over the years, scientists have wrestled with some mind-bending questions about the universe, its edges, its origins, its secrets. But here's one theory that's shaking up how we look at it all. A growing number of researchers believe that we might actually be living inside a black hole. Yeah, a black hole, with all of us, our planet, and every star we can see, all tucked away in a massive cosmic container. Today, let's dive deep into why scientists are exploring this radical idea and what it could mean for us. All right, let's start with the basics. Black holes are, without a doubt, some of the strangest, scariest, and most fascinating objects in the universe. They're these dense, massive regions of space with gravity so strong that nothing, not light, not time, not even the universe's fastest particles, can escape once it gets close enough. When something crosses the event horizon, that invisible line of no return, it's gone for good, pulled into the black hole's powerful grip. But here's the twist. What if black holes aren't just cosmic traps, but cosmic containers? What if, inside these super-dense regions, they're actually housing whole other universes? This idea might sound straight out of a sci-fi movie, but it's a real hypothesis scientists are studying. And as crazy as it sounds, it could solve some of the biggest mysteries we have about the universe. All right, to really dive into this idea of living inside a black hole, we need to first understand what a black hole is, and why it's such a mysterious and intense phenomenon in space. So imagine a star, a huge burning ball of gas that's lived for millions or even billions of years. Like everything, stars have life cycles. They're born, they burn, and eventually, they die. For really massive stars, this end-of-life phase is dramatic and explosive. Once these stars burn through their fuel, they undergo a massive collapse, a sort of implosion, where all of that mass gets crunched down into an extremely dense core. We're talking about something so dense that a star's entire mass, sometimes many times the mass of our sun, ends up compressed into an area that's just a few miles wide. Now, this super dense core has an intense gravitational pull. It's so powerful that it bends the fabric of space and time around it. To give you an idea, it's like if you had a trampoline and you placed a bowling ball in the center. The surface of the trampoline would bend and sink around the bowling ball. Well, black holes do that on an even more extreme scale. They're bending and warping space-time so much that it forms what we call a singularity, a point where gravity is so intense that the laws of physics as we know them seem to break down. One of the most famous parts of a black hole is the event horizon. This is the boundary or edge of the black hole, the line that marks the point of no return. Once anything crosses this line, whether it's a planet, a star, or even light itself, it's pulled towards the center of the black hole with no chance of escape. The gravity within a black hole is just too strong to resist once you're past this event horizon. What's even more fascinating is that from the outside, it appears as though time itself slows down the closer you get to the event horizon. This effect is due to something called gravitational time dilation. So, if you were watching someone fall into a black hole from a safe distance, it would look like they're moving slower and slower as they approach the event horizon, until they almost seem frozen in time. In reality, for the person falling in, they'd be moving normally, but would cross the event horizon, unable to return or communicate back. But inside the black hole, beyond this event horizon, is where things get really strange. This is the no man's land of the universe, a place we can't see, can't reach, and frankly, don't fully understand. Scientists believe that once you're inside, you'd be drawn towards the center, the singularity, where all of the black hole's mass is concentrated. But we still don't know exactly what would happen because the conditions are so extreme that our current understanding of physics can't fully explain it. Now, here's where it connects to our universe and the theory we're exploring today. Some scientists propose that inside these singularities, inside these black holes, could lie entire universes. Just as our universe might be contained within a black hole, each black hole in our universe could contain its own universe within it. Imagine it, black holes as gateways to other universes, each with their own galaxies, stars, and perhaps even life. This brings us back to our main question. Could we, in fact, be living inside a black hole? If black holes have this potential to hold entire universes within them, it's possible that our universe could be just one of many, each tucked inside its own cosmic bubble, waiting to be discovered. So, let's take this idea a bit further. What if black holes aren't just cosmic trash compactors, swallowing everything around them? What if they're actually cosmic containers, or gateways, that hold entire universes within them? This idea might sound far-fetched, but it's a hypothesis that many scientists and astrophysicists are seriously considering. And believe it or not, it could explain some of the biggest mysteries we have about our own universe. Think about it. Every black hole has an event horizon, a boundary beyond which nothing can escape. Once something crosses this event horizon, it's trapped and pulled toward the center, toward a point known as the singularity. The singularity is the core of a black hole, and it's where all of the black hole's mass is concentrated. In theory, the singularity is infinitely dense, which means that all the mass and energy of whatever the black hole has consumed is compressed into an incredibly tiny space. It's a place where the laws of physics, as we currently understand them, completely break down. But here's where it gets really interesting. Some scientists propose that the conditions inside a black hole might actually be perfect for creating a universe. Imagine if, instead of everything just being crushed and destroyed in the singularity, it somehow triggers a kind of Big Bang of its own, a singularity that leads to the birth of an entirely new universe within the black hole. Just like our universe is thought to have begun with the Big Bang, where all matter and energy exploded from an incredibly hot and dense point, these black hole singularities might have the potential to spawn whole universes, each with its own galaxies, stars, and planets. This theory is rooted in a field of study called cosmology, the science of understanding the origins and structure of the universe. Cosmologists are constantly trying to answer the question, where did we come from, and what is the universe really made of? And in the past few decades, cosmologists have developed a lot of new ideas about how our universe might actually be connected to black holes. Some even suggest that our own universe might exist within a black hole that's part of a much larger universe. One of the big clues comes from something known as the multiverse theory. According to this theory, our universe isn't the only one. Instead, there are countless other universes, all with their own unique properties and physical laws. These universes could be right next to ours, like bubbles in a vast ocean of universes. The multiverse theory suggests that each black hole could be a gateway to one of these bubble universes, where entirely different realities might exist. Think about it this way. When a star collapses and forms a black hole, that black hole might essentially create a new universe inside of it. The gravitational pull of the black hole could seal this universe within its event horizon, keeping it isolated from other universes in the multiverse. This isolation could explain why each universe has its own set of physical laws, and why we don't see any evidence of other universes interacting with ours. Every black hole could contain a completely separate reality, a pocket of space-time that exists independently from everything else. But if each black hole contains a universe, that also means that our own universe could be inside a black hole, right? This idea isn't just science fiction. It's something that some of the world's most renowned physicists, including people like Stephen Hawking and Roger Penrose, have suggested might actually be possible. They argue that just as black holes seem to trap matter and energy, our universe might be one of these trapped pockets of reality. So, why would scientists believe this? Well, let's think about the Big Bang for a second. The Big Bang is the event that's believed to have created our universe around 13.8 billion years ago. In this event, all the matter, energy, and space-time in the universe exploded outward from an incredibly dense and hot point. This starting point sounds a lot like a singularity, the very thing that lies at the center of a black hole, It's as if the conditions for the Big Bang and the conditions inside a black hole singularity are somehow similar. Both involve immense densities and extreme temperatures, conditions that can give birth to something entirely new. In fact, some scientists suggest that our universe's Big Bang could have been the result of a black hole in another, older universe. If that's true, then our universe is essentially a child universe, created when a black hole in another universe reached a critical point and triggered a new Big Bang within its singularity. So, in a way, every black hole could be like a cosmic seed that creates a new universe, and every universe might contain countless black holes, each one possibly housing a universe of its own. This concept is known as the cosmic nesting doll model, or sometimes the Russian doll universe. It's the idea that universes could be nested within each other, each one contained within a black hole in a larger universe. And this structure could go on forever, like layers in an infinite cosmic onion. The outer universe might have black holes that contain other universes, and those universes could have black holes containing more universes, and so on. Now you might be wondering, if black holes are so destructive, how could life or galaxies or planets exist inside them? It's a fair question. But remember, what's destructive to us in our own universe might actually be completely different in another. The laws of physics inside a black hole might be vastly different from the laws of physics in our own universe. Inside a black hole, there might be enough time, space, and stability for a universe to form and evolve, just like our own. Some scientists believe that each black hole could have its own unique set of physical laws. For example, gravity might work differently, time might flow at a different rate, and the fundamental particles that make up matter could be entirely different from those in our universe. This is part of what makes the multiverse theory so interesting. It suggests that there could be endless variations of reality, each universe evolving and developing in its own way. Think of each black hole as a kind of cosmic cocoon. Just like a caterpillar forms a cocoon and transforms into something completely different, a black hole could be a cosmic cocoon that gives birth to a new universe, each one emerging with its own distinct properties. This theory could also explain why black holes seem to last forever, because they're essentially universes in their own right, with vast amounts of time and space compressed within them. But if all of this is true, it opens up some incredible possibilities. For one, it means that our universe might not be as unique as we think. It might be one of billions, or even trillions of universes, each one born from a black hole in some other universe. Our entire existence could be just a tiny part of a much larger and more complex multiverse, with endless realms and realities branching off in every direction. And it also means that everything we know, the stars, the galaxies, even our own sense of reality, might be confined within the boundaries of a black hole. We're essentially living inside this cosmic bubble, isolated from the rest of the multiverse by our own event horizon. And beyond that horizon, there could be other universes just like ours, each one containing its own galaxies, stars, and possibly even life. Some scientists even suggest that if this theory is true, then our entire understanding of space and time could change. We might discover that there's a whole new set of rules governing the multiverse, rules that go beyond our current understanding of physics, and maybe one day we'll even find a way to observe or interact with other universes within black holes. But for now, this idea remains a fascinating and mind-bending hypothesis. We may never know for certain if we're living inside a black hole, or if black holes really do contain entire universes. But one thing is for sure, the universe is full of mysteries, and black holes are among the greatest mysteries of all. So, next time you look up at the stars, remember, you might just be gazing into the depths of a black hole, a cosmic cradle that holds our entire universe within it. To really grasp the idea that black holes might contain entire universes, or even that our universe could be inside a black hole, we need to dive into two major theories in physics: Einstein's theory of general relativity and quantum mechanics. These two theories are the foundation of modern physics, and they each describe the universe in ways that are incredibly useful, but also incredibly different. And while they both help us understand how the universe works, they don't always agree with each other, especially when it comes to something as extreme as a black hole. Let's start with Einstein's theory of general relativity. General relativity explains how gravity works on a large scale, like planets orbiting stars, stars forming galaxies, and galaxies shaping the universe itself. According to Einstein, gravity isn't really a force in the way we usually think of it. Instead, it's a result of the way mass warps space and time around it. Imagine placing a bowling ball on a trampoline. The weight of the ball stretches and bends the fabric of the trampoline, creating a dip. If you then roll a marble across the trampoline, it will curve around the bowling ball, drawn toward it by the dip in the surface. That's essentially how general relativity describes gravity. Objects with mass bend the fabric of space-time, and other objects fall along those curves. Now, general relativity does a fantastic job explaining how gravity affects large objects, like planets, stars, and galaxies. But when you zoom in really close, down to the level of particles like electrons and quarks, general relativity starts to fall apart. This is where quantum mechanics comes in. Quantum mechanics is the branch of physics that describes how the smallest particles in the universe behave. It's weird and counterintuitive in a lot of ways, because particles at this scale don't always behave in predictable ways. In fact, they can exist in more than one place at the same time, move in ways that defy classical physics, and even teleport from one location to another. These particles are affected by quantum forces, which are very different from the gravitational forces described by general relativity. So here's the big problem. When we try to use both general relativity and quantum mechanics to describe a black hole, we end up with contradictions. According to general relativity, a black hole is defined by its event horizon, the boundary beyond which nothing can escape, and its singularity, where the mass is so dense that it theoretically has infinite density. But quantum mechanics tells us that information, the essential details of particles and energy, can't simply be lost. And yet, if you throw something into a black hole, it disappears forever beyond the event horizon. So, where does that information go? This conflict is known as the information paradox, and it's one of the biggest mysteries in modern physics. One of the reasons why black holes are so fascinating is that they're the ultimate testing grounds for these two theories. They're regions of extreme gravity and extreme density, exactly where general relativity and quantum mechanics come into direct conflict. Some physicists believe that if we can figure out how black holes work, we might finally be able to unify these two theories into a single framework that explains everything in the universe, from the tiniest particles to the largest galaxies. This unified theory is often called the theory of everything. And it's something scientists have been searching for decades. This is where the idea of black holes containing universes could actually help bridge the gap. Some physicists believe that inside a black hole, both general relativity and quantum mechanics might operate in harmony. How? Well, one theory suggests that when a black hole forms, it creates a bubble, a self-contained region of space and time that's effectively cut off from the rest of the universe. This bubble could have its own rules, its own laws of physics that are slightly different from those outside the black hole. In other words, the intense gravity of a black hole could warp space and time to such an extreme degree that a new, separate universe is created within it, governed by its own set of laws. This is where holographic theory comes in. Holographic theory is an idea that's been gaining traction in the field of theoretical physics, and it suggests that everything we perceive as three-dimensional might actually be encoded on a two-dimensional surface. Think of it like a hologram, where a flat image appears to have depth. According to holographic theory, the entire universe could be a kind of hologram, where all the information needed to describe everything inside it is stored on a two-dimensional surface at the edge of the universe. Now let's bring this back to black holes. The event horizon of a black hole could serve as this two-dimensional surface that encodes everything happening inside it. So, while it might look like objects disappear when they cross the event horizon, all the information about them might actually be stored on the surface itself, like data on a hard drive. This idea could resolve the information paradox because it suggests that information isn't actually lost when something falls into a black hole. Instead, it's encoded on the event horizon, preserving it in some form even if the object itself is destroyed inside the black hole. But there's more. Some scientists think that this holographic model could apply to entire universes, just as the event horizon of a black hole might contain all the information within it. The edge of our universe, the cosmic horizon, might contain all the information of our entire reality. In other words, our universe could be a kind of hologram projected from a two-dimensional surface, and black holes could be windows into these holographic realities. So, if we're living in a universe inside a black hole, it could mean that all of our reality is actually encoded on the event horizon of that black hole. This holographic principle could also explain why different universes within different black holes might have different laws of physics. Each black hole's event horizon could encode a unique program that governs the rules of the universe within it. In one black hole universe, gravity might be stronger, time might move faster, or particles might behave in entirely new ways. Each universe would be a kind of cosmic experiment with its own distinct set of laws and conditions. The implications of this are mind-blowing. For one, it suggests that our universe might just be one of many, each encoded on the event horizon of a different black hole in some larger universe. And this larger universe could itself be part of an even greater structure, with its own black holes containing their own nested universes, like an infinite series of Russian dolls. And each of these universes would have its own unique identity, defined by the specific conditions encoded on its event horizon. Another possibility is that if black holes really do contain universes, then these universes might occasionally interact with each other in subtle ways. Some scientists suggest that certain phenomena in our universe, such as the presence of dark matter or the acceleration of cosmic expansion, could be influenced by forces from neighboring universes. These forces might leak into our universe through the boundaries of our black hole, subtly shaping our reality. This theory could also shed light on why our universe appears to be so finely tuned for life. The conditions that allow for life, things like the strength of gravity, the behavior of atoms, and the speed of light, are incredibly specific. If any of these values were slightly different, life as we know it might not be possible. Some physicists believe that if there are countless universes within black holes, each with slightly different physical laws, then it's not surprising that at least one of these universes would have the right conditions for life. We just happen to live in one of the lucky universes where everything lined up just right. This all leads to a profound question. If universes are constantly being created within black holes, could our universe one day give rise to new universes of its own? In other words, could the black holes within our universe contain entire realities that are yet to be born? If this is the case, then our universe isn't just a passive part of the multiverse. It's an active participant in the creation of new realities, each with its own possibilities and mysteries. But perhaps the most mind-bending idea of all is that we could be on the verge of a new era in physics, where we finally bridge the gap between general relativity and quantum mechanics. If black holes are the key to unifying these two theories, then studying them might lead us to a theory of everything, a single, elegant framework that explains every force, every particle, and every mystery in the cosmos. And who knows? Maybe one day we'll even find a way to explore these hidden universes within black holes, opening the door to an entirely new frontier of knowledge. To understand why some scientists seriously consider the idea that black holes could contain entire universes, let's dive into some key observations and findings that have led researchers to this mind-bending hypothesis. These observations aren't just theoretical guesses. They come from studying the behavior of black holes, exploring the limits of space, and analyzing the vast, expanding nature of our own universe. Together, they build a picture that makes this radical idea more plausible than you might expect. First, let's look at one of the most well-known features of our universe, its expansion. When astronomers observe distant galaxies, they notice that these galaxies are moving away from us, and the further they are, the faster they seem to be receding. This phenomenon is known as the cosmic expansion. And it suggests that the universe has been stretching outwards ever since the Big Bang. You can think of it like a balloon being inflated, with galaxies scattered across its surface. As the balloon expands, the galaxies move farther apart, giving us a clear indication that space itself is growing. This expansion led scientists to conclude that our universe likely began as an incredibly hot, dense point that suddenly expanded, an event we call the Big Bang. But here's the twist. The way our universe is expanding has some eerie similarities to how objects behave around black holes. Just like galaxies are stuck within the expanding space of our universe, objects near a black hole are pulled towards its center, unable to escape beyond its event horizon. This has led some scientists to wonder if our universe might have a similar event horizon, a boundary beyond which we can't observe or interact. If that's true, it raises the possibility that our universe could be a sort of inside-out black hole, where the event horizon keeps everything within it contained, much like a black hole's event horizon does. One of the scientists who explored this idea was the legendary physicist Stephen Hawking. Hawking's groundbreaking work on black holes helped us understand that they aren't just cosmic vacuum cleaners that pull in matter and trap it forever. Instead, Hawking proposed that black holes emit a type of radiation, now known as Hawking radiation, which allows them to slowly lose mass over time. This discovery changed the way we look at black holes because it means they might not be permanent. They could eventually evaporate and disappear. But it also raised another question. If black holes release radiation, what happens to the information about everything that was swallowed by the black hole? This question is central to the information paradox. In classical physics, information about a physical system, like the specific characteristics of a particle, can never be truly lost. It might be rearranged, transformed, or hidden, but it should always be possible to reconstruct it. However, if a black hole can evaporate and disappear, as Hawking suggested, then what happens to the information about everything that fell into it? If black holes contain universes within them, it might offer a solution. Rather than being destroyed, that information could be reorganized into a new universe inside the black hole, preserving it in a way that's hidden from our own universe. Adding to this theory, Leonard Susskind, another influential physicist, proposed the concept of the holographic principle. This principle suggests that all the information about what's inside a black hole could actually be encoded on its surface, the event horizon. Susskind's idea challenges the traditional way we think about dimensions and reality. According to the holographic principle, our three-dimensional reality could be an illusion, a projection of information stored on a two-dimensional surface. Imagine a hologram, where a flat image appears to have depth and detail. Susskind suggested that black holes, and potentially our entire universe, might work in a similar way. The inside of a black hole could be a fully realized reality, while all the information about that reality is stored on the event horizon itself. This theory might sound strange, but it's gained a lot of traction among physicists because it offers a way to resolve the information paradox and hints at a much larger, interconnected structure within the cosmos. If black holes are holographic in nature, then the entire universe could be a hologram, where each black hole's event horizon encodes the details of a separate universe. Our universe might even be stored on the event horizon of a black hole in a much larger cosmos, making our reality a projection of that information. Another major piece of evidence comes from the mysterious force known as dark energy. Dark energy is an invisible force that's driving the accelerated expansion of our universe. Scientists don't fully understand what dark energy is or where it comes from, but it seems to be the dominant force in our universe, accounting for about 68% of all the energy in existence. One possible explanation for dark energy is that it might be a result of our universe being stretched within a black hole. If we're inside a black hole, then the gravitational effects from the outer universe could be causing this accelerated expansion, pushing our space-time outward, just like the edge of a balloon being inflated. Let's also talk about dark matter, another cosmic mystery. Dark matter makes up about 27% of our universe, yet we can't see it or directly detect it. We only know it's there because of the gravitational effects it has on visible matter, like galaxies and stars. Dark matter seems to bind galaxies together, providing the extra gravitational pull needed to keep them from drifting apart. Some scientists think dark matter might be an indication of forces from outside our universe affecting us. If we're inside a black hole, then dark matter might be a form of gravitational influence from the larger universe containing our black hole. This would mean that what we perceive as dark matter is actually a subtle effect from the massive structure outside our universe. One of the most fascinating observations in recent years has come from the Event Horizon Telescope, EHT, a global network of telescopes that captured the first ever image of a black hole's event horizon in 2019. This image showed us, for the first time, the shadow of a black hole, an outline of the event horizon surrounded by glowing matter being pulled toward it. The image provided a direct glimpse of the edge of a black hole and confirmed many predictions made by Einstein's theory of general relativity. But it also sparked new questions, particularly about what lies beyond the event horizon. If our universe exists within a black hole, then the event horizon we observed might be similar to the boundary of our own universe, beyond which lies an entirely different reality. Additionally, the observation of gravitational waves, ripples in the fabric of spacetime, has opened up new ways to study black holes. Gravitational waves are created when massive objects, like black holes, collide and merge. The detection of these waves confirmed another of Einstein's predictions and gave scientists a new tool to observe cosmic events that were previously invisible. By studying these waves, scientists have been able to learn more about the behavior of black holes, including how they interact and merge. Some researchers suggest that if black holes do contain universes, then the merging of black holes might cause interactions between those universes. The ripple effects from these collisions could be a way for information or energy to transfer across different universes, connecting them in ways we're only beginning to understand. Perhaps the most mind-bending observation that supports this theory is the concept of cosmic censorship. This is the idea that the laws of physics censor certain events or information from us, hiding the singularity at the center of a black hole behind the event horizon. According to this principle, the singularity is inaccessible from our universe, making it impossible for us to observe directly. This cosmic censorship might be what allows each black hole to contain a unique universe within it, isolating it from all other universes. Our universe might be isolated within the event horizon of a black hole in a larger cosmos, with cosmic censorship preventing us from ever seeing beyond that boundary. These observations and theories all point toward the possibility that black holes might be more than just massive gravitational traps. Instead, they could be gateways or containers for entire universes, with each black hole holding its own unique reality. This theory is incredibly difficult to prove, but with advancements in technology, like the Event Horizon Telescope and gravitational wave detectors, scientists are getting closer to understanding the true nature of black holes and their potential as cosmic cradles of new universes. In summary, the observations of cosmic expansion, the effects of dark matter and dark energy, the holographic principle, and recent black hole imaging all provide tantalizing hints that our universe could, in fact, exist within a black hole. These discoveries offer a glimpse into what lies beyond our universe's boundaries, challenging us to rethink our place in the cosmos and consider the possibility that our universe is just one part of a much larger multiverse, each universe born within the confines of a black hole. Let's think for a moment about some of the biggest mysteries in science, questions that have baffled physicists, cosmologists, and philosophers for centuries. Questions like, What is dark matter? What is dark energy? Why did the universe start with a Big Bang? And perhaps the biggest one of all, why does the universe seem so perfectly fine-tuned for life? If we're inside a black hole that contains our universe, these mysteries might start to make more sense, and the pieces of the cosmic puzzle might finally fit together. First up is dark matter, one of the universe's most elusive substances. About 27% of the universe's total mass energy content is thought to be dark matter, yet we can't see it, touch it, or even detect it directly. Dark matter doesn't emit light or energy, which is why it's dark, but we know it's there because of its gravitational effects. It seems to hold galaxies together, giving them the extra gravitational pull needed to keep stars in orbit, even though there doesn't appear to be enough visible matter to account for this pull. If we're living inside a black hole, then dark matter might be the result of gravitational effects from outside our universe. Just like we feel the pull of gravity from objects in our universe, there could be gravitational influences from a larger, external universe affecting ours. This would mean that what we perceive as dark matter isn't a separate substance at all, but rather a kind of gravitational bleed from a greater universe containing our black hole. In other words, dark matter might just be an effect of the massive structure outside of our universe, impacting us in subtle but measurable ways. Next, let's talk about dark energy, another mysterious force that plays a huge role in the universe's evolution. While dark matter makes up about 27% of the universe, dark energy accounts for about 68%. Dark energy is thought to be responsible for the accelerated expansion of the universe. In simple terms, it's the force that's pushing galaxies apart at an ever-increasing rate. But why is the universe expanding like this? And where does this energy come from? If we're inside a black hole, then the pull of gravity from the larger universe could be stretching our space-time outward, causing this accelerated expansion. To visualize this, imagine blowing up a balloon. As you inflate it, points on the surface of the balloon move further apart. Similarly, if our universe is inside a black hole, then the gravitational influence from outside could be inflating our universe, making it expand faster and faster. This could mean that dark energy is essentially an effect of the greater universe's gravitational force interacting with our own, stretching space-time in all directions. Another major mystery this theory could explain is the Big Bang. The Big Bang is the event believed to have created our universe around 13.8 billion years ago. Scientists think the universe started as an incredibly hot, dense point, which suddenly expanded and began to cool, forming stars, galaxies, and eventually planets. But no one really knows what caused the Big Bang or why the universe began in such a hot, dense state. If our universe exists within a black hole, then the Big Bang could actually be the moment when this black hole was formed in a larger universe. Imagine a massive star in another universe collapsing in on itself to form a black hole. In that moment, the intense gravitational collapse might have created a bubble inside the black hole's event horizon, a self-contained space-time that rapidly expanded, giving rise to a new universe. That rapid expansion within the black hole could look a lot like what we observe as the Big Bang. This theory suggests that every black hole could be the birth of a new universe, meaning our universe is just one in an endless cycle of universes, each born from the collapse of a star in a previous universe. But it doesn't stop there. This theory could also explain why our universe seems so perfectly tuned for life. Scientists have long noted that the universe's physical laws are surprisingly balanced in a way that allows for the existence of complex structures, including stars, planets, and life. If any of the fundamental constants of the universe, like the speed of light, the strength of gravity, or the properties of particles, were even slightly different, life as we know it might not be possible. This has led to what's known as the fine-tuning problem. Why does the universe seem to be set up in such a way that life can exist? One possible answer is that if there are countless universes within countless black holes, each one could have its own unique set of physical laws and constants. In some of these universes, conditions might be completely hostile to life. Gravity might be too strong, or particles might behave in ways that prevent stars from forming. In others, conditions might be similar to our own, allowing stars, planets, and life to exist. This idea is part of the SARAO multiverse theory, which suggests that our universe is just one of many, each with its own set of rules. We happen to live in a universe where the conditions are just right for life, simply because we wouldn't be here to observe it if they weren't. This theory could also help explain quantum mechanics, particularly the strange behavior of particles on a very small scale. Quantum mechanics describes a world that doesn't behave in predictable ways. Particles can exist in more than one place at once, tunnel through barriers, and even teleport from one location to another. These behaviors seem bizarre and contradict the rules of classical physics, which govern the larger objects we see every day. But if our universe exists within a black hole, it's possible that the laws of quantum mechanics are actually the result of influences from outside our universe. For example, the uncertainty we see in quantum mechanics, the fact that we can't precisely measure both the position and momentum of a particle, might be due to gravitational influences from the larger universe. If the space-time inside our universe is constantly being affected by forces from outside, it could create a kind of fuzziness or unpredictability at the quantum level. This could mean that the strange behavior of particles is, in part, a side effect of our universe's unique environment within a black hole. Even the idea of why time itself might be explained by this theory. In our universe, time seems to move in one direction, from past to future. But in a black hole, time might behave differently. Close to the event horizon, time appears to slow down relative to an outside observer. If our universe is inside a black hole, the way we experience time might be the result of the extreme conditions within this black hole. This could mean that time in our universe is not an absolute property, but rather a consequence of the space-time conditions in our cosmic bubble. The implications of this theory are mind-boggling. It suggests that everything we know, from the behavior of galaxies to the particles that make up matter, might be influenced by forces and structures beyond our universe's boundaries. Dark matter and dark energy, the Big Bang, the fine-tuning of physical constants, and even the nature of time and quantum mechanics might all be explained if our universe is one of many inside black holes scattered throughout a much larger cosmos. And perhaps most astonishing of all is that this theory hints at the possibility of a kind of cosmic ecosystem of universes, each one born from the black holes in another universe. This would mean that universes are constantly being created and destroyed in a vast interconnected web of realities. Our universe might be just one generation in a chain of universes stretching infinitely into the past and future. And each universe could be producing its own black holes, giving birth to new universes with their own unique characteristics and possibilities. Ultimately, this theory changes how we see ourselves and our place in the cosmos. We may not be living in an isolated universe, but rather in a universe that's part of an infinite multiverse, each universe contained within black holes in others. It's a humbling and exhilarating thought, suggesting that we're part of something far bigger and more complex than we could have ever imagined. So, in summary, this idea that we live inside a black hole doesn't just give us a new way of looking at black holes. It gives us a new way of looking at the universe itself. It offers possible explanations for dark matter, dark energy, the Big Bang, quantum mechanics, and the fine-tuning of physical laws for life. This theory could be the key to answering some of the biggest questions we have about the nature of reality and our place in it. But here's the real mind-bender. If we're living in a universe inside a black hole, what's outside? Could there be an even bigger black hole out there containing us, and maybe other black holes with other universes like ours? Imagine an endless chain of universes inside black holes inside universes. This is the idea of a multiverse, an infinite number of universes, all with their own unique rules, tucked away inside each other. This theory, if true, changes everything. It would mean that we're not the center of the universe or even a single isolated universe. We're just one universe in a cosmic web of black holes, all connected, all part of an endless multiverse. And what's really wild is that the boundaries between universes might not be as distant as we think. Our universe could be one of many, all stacked within each other, like cosmic Russian dolls, each universe hiding its own secrets. If you enjoyed this journey into the mysteries of the cosmos, make sure to hit subscribe for more explorations like this one.